we all experience time, right? Like it's how we plan our day, how we understand the world around us. But what if I told you that time, the way we think about it, might actually be an illusion?
It's a pretty wild thought.
It is. It
Yeah.
really is. I mean, we're going to get into this idea that time might actually be a side effect of something called quantum entanglement.
Yeah. It's all pretty mind-bending stuff.
It is. And to get to the bottom of it, I think we need to kind of start with this idea of quantum superposition.
Right.
I've always had trouble wrapping my brain around this one.
Absolutely. It's one of the core concepts in quantum mechanics, and it's definitely counterintuitive. So to try and understand it, let's imagine flipping a coin but not looking at the result. So before you peek, is it heads or tails?
Well, it has to be one or the other, right?
That's what our everyday experience tells us. But in the quantum world, it's actually both at the same time. Until you look at the coin, it exists in this blurry state of being both heads and tails simultaneously.
Okay, so it's not just coins, though, right?
That-
This applies to particles, too.
Exactly. That's right. If you shine a light at a beam splitter, sending a single photon towards it, is that photon going through path A or path B?
I would think it would have to be one or the other.
Again, that's what our classical intuition would suggest, but until you actually measure it, that photon is in both paths at the same time. And this is where it gets really strange.
So how do we know that?
Well, if you try to explain the results of certain experiments by assuming the photon was always in one path, things just don't add up. The math doesn't work, the predictions don't match what we observe. So this is how we know that the quantum world operates in ways that defy our everyday intuition.
Right, so then where does this idea of entanglement come in?
Entanglement is a special kind of superposition where two particles are linked no matter how far apart they are. And this is where it gets really mind-blowing, because if you measure the state of one particle, you instantly know the state of the other, even if they're light years away.
So they're communicating faster than the speed of light.
Not quite. It's not that there's some faster than light signaling going on. It's more like they're two sides of the same coin, even when separated by vast distances. And this brings us to this crazy idea that this spooky action at a distance, this entanglement might be the very source of what we perceive as time.
Wow, okay, so I read that when two photons are emitted from a source, they're always entangled.
That's right.
And their polarizations might be random, but the twins always match perfectly no matter what. It's kind of like having these magical loaded dice that always roll the same number even though you don't know what that number is until you look.
That's a great analogy. And that behavior of entangled photons is actually a key ingredient in something called the Page and Wooders mechanism, which basically says that time emerges from the entanglement between an object and a clock.
Wait, so a clock, like a clock on the wall.
Not necessarily a physical clock. Think of it more like a system that keeps track of change. The idea is that without this entanglement between objects and their clocks, the entire universe would be frozen in a single unchanging state. There would be no before or after, no flow of time as we know it.
Right, so I also read about this study where researchers created a mathematical model to test this idea.
Yes.
They used a vibrating object, these tiny magnets, as their clock. And the crazy thing is, their calculations actually work perfectly with the fundamental laws of quantum mechanics.
It's amazing, isn't it? It's like the math checks out even at the quantum level.
Totally. And then it gets even more interesting because when they scaled up their model to objects that we interact with in everyday life, what we call macroscopic objects, their equations simplified into the classical physics equations we use to describe the world around us.
Precisely.
So you're saying that even at our scale, the flow of time we experience could be a result of this entanglement at a fundamental level.
That's the implication. It suggests that this quantum weirdness might be the very foundation upon which our everyday reality is built. But of course, as with any groundbreaking idea, not everyone is convinced. Some scientists remain skeptical, arguing that we need more concrete evidence before we can truly say that time is an emergent property of entanglement.
Right. And I read this quote from a physicist who was wondering if we could even really comprehend time from an objective outside perspective. Like maybe our experience of time is inherently tied to our existence as living beings within this universe.
It's a really deep thought. It makes you wonder if time as we know it is more of a story we tell ourselves, a way of making sense of the constant flux of change in the universe.
Much to think about.
Absolutely. Really challenges how we think about the universe, doesn't it?
Totally. Like, if time isn't this fixed thing, universal thing, what does that even mean for, like, cause and effect? You know, if time is more like this tapestry woven from entanglement, is the future, like, set in stone, or are there different possibilities?
Those are some of the biggest questions we have in physics, and honestly, we're just scratching the surface here. If time really is an emergent property, it could very well mean that our linear view of the past, present, and future is a little too simple. Like we're trying to understand this 3D object, but we're only looking at its shadow.
So you're saying the future isn't fixed? Like, do I even have free will then? Or is everything already predetermined?
Yeah.
It's kind of like one of those sci-fi movies where they mess around with time travel.
You know, it might help to think of it less like a fixed timeline and more like a branching tree. At every single moment, there are multiple different possibilities, and maybe our choices are kind of like navigating the branches on that tree. Some people even think that when we observe something that actually plays a part in collapsing those possibilities into the reality that we actually experience.
Whoa, okay, there's a lot there.
Yeah.
But if time isn't this rigid framework, then what about the past? Is that set in stone, or could it be constantly shifting based on this, web of entanglement?
It's so interesting to think about, right? Because if the past is also entangled with the present and the future, it might not be as unchangeable as we tend to think. Maybe it's more like a fluid narrative that is constantly being rewritten as the universe evolves.
So my memory of that super embarrassing moment from high school could be changing right now because of some quantum event happening on a star thousands of light years away.
Well, it might not be quite as literal as that. The point is that our understanding of time is probably much more complex and interconnected than we can even imagine. It might not be a simple arrow, pointing from the past to the future, but something much weirder and much richer.
Okay, my head is officially spinning. But in a good way, I think. But if time isn't this absolute ruler that we always thought it was, does that mean that it can, speed up or slow down? Like, we all know that saying time flies when you're having fun.
Yeah, and that saying might actually be more profound than we realize, because our perception of time is definitely subjective. Think about it. Time seems to just crawl by when you're bored or terrified, but it just flies when you're doing something you love. Those aren't just feelings, they reflect how our brains are actually processing information and creating that sense of time that we have internally.
It's like when you're a kid, summer vacation feels like it lasts forever, but then as you get older, the years just zoom by.
Exactly. As we experience more and more our internal clocks, the way our brains interpret and organize all that information, they might be changing too. It's not that time itself is speeding up, but our perception of it is changing.
So are you saying that time is all in our heads? It's just a product of our perception?
It's a little bit more nuanced than that, I would say. Our experience of time is definitely shaped by how our brains interact with the universe with this underlying quantum reality. Think of it more as a collaboration. The universe gives us the raw materials, and our brains kind of weave that into this tapestry of time that we each experience.
It makes you wonder if we're even asking, like, the right questions about time.
Yeah, maybe our current understanding of time is just too limited, like trying to describe a symphony, but you've only heard one note.
So if entanglement is the key to understanding time, what's next? Like, can we even test this idea?
That's what's so exciting about it. Finding ways to connect these mind-boggling theories to something we can actually measure in a lab is going to be crucial. And there are some brilliant people out there working on it, trying to tackle this challenge. If we can figure out how to manipulate entanglement on a larger scale, who knows what we might uncover? It could completely revolutionize how we understand the universe.
It's pretty incredible to think about. So next time I look at my watch, I'll have to remember that time might just be a trick of these entangled quantum particles, this cosmic dance playing out on a scale we're only beginning to understand.
Exactly. And it might be a trick that's fundamental to, like, the very fabric of reality.
This whole conversation has been a wild ride. It really makes you question everything you thought you knew about time.
It definitely challenges our assumptions and opens up a whole new world of possibilities.
We've given you a lot to think about today. Hopefully enough to make you look at time in a whole new light.
Yeah, and maybe next time you check the clock, you'll do it with a sense of wonder and curiosity, knowing that there's this hidden world of quantum strangeness ticking away beneath the surface.
And if you're looking for a soundtrack to accompany your newfound perspective on time, I highly recommend checking out the song Time of Illusion by DOA. It seems pretty fitting for our discussion today.
Until next time, keep questioning, keep exploring, and keep an eye on that clock. Or should I say, keep an eye on that entangled web of quantum possibilities.